Now my fifth grader has a joke he wants to share with you. Which side of a duck has the most feathers? The outside. Huh? All right, now we are going to learn a new way to solve systems of equations. Solving by substitution, we learned last week. This week we're going to learn solving by elimination. So take a minute to think about what elimination means. It means getting rid of something or canceling something. So when we solve a system by elimination, we are going to cancel one of the variables. So our first example, notice we do not have one variable all alone on one side of the equal sign. So this one is not set up nicely for solving by substitution. Looking at step 1 in that right-hand column, when we solve by elimination, we actually add the equations together. So notice these are lined up so that our like terms are on the same side of the equal sign. We have 3x plus 4x equals 7x. Negative 2y plus 2y, those cancel or eliminate, and then we'll bring down the equal sign. That's got to stay in the same spot as well, and 0 plus 14 is still 14. Notice we now have one equation with one variable, so we can solve this to get x alone. Dividing both sides by 7, I get x equals 2. What's nice about solving by elimination is that it's pretty quick to get the first variable solved for, but it does take a little bit more work to get the second variable solved for. That's actually the opposite of solving by substitution. It's a longer process to solve for the first variable, and it's pretty quick to solve for the second. Now what we do is we can choose either one of those original equations. I like the first one, so I'm going to replace x with 2. I'm still using substitution for this one, just a different kind of substitution. Minus 2y equals 0. Now my goal is to get y alone. So I'm going to start by multiplying my 3 times 2 together. Now we have a two-step. So to get y alone, we'll start by canceling the 6. Notice the 6 is positive and the 2 is negative. So when I cancel my positive 6, I will subtract it, and that leaves me with a negative 2y. Keep track of those negative signs. And finally, we'll divide both sides by negative 2, leaving me with y equals a positive 3. Those negatives will cancel each other out. Writing my solution as an ordered pair, I got an x value of 2 and a y value of 3. All right, I'm going to clear out this canceling here because what I want to do before we move on is take a look at why, when we added these equations together, we got a variable to cancel. So notice in front of my y's, they had the same coefficient. They were both being multiplied by a 2, except one of the 2's was positive and one was negative. So that's what we need in order to get a variable to cancel. Now, of course, not all equations are going to be set up perfectly for us so that we can just add them together and get them to cancel. So let's take a look at example 2. We're going to study those coefficients. We have a 3x and a 3x. So I'm close. They're both a 3, but they're both positive. So if I added these equations together right now, my x's would not cancel. They would combine to give me a total of 6 x's. So let's take a look at the y's. We have a negative 4y and a positive 2y. So they have opposite signs, which is good, but negative 4 plus 2 won't cancel either. So what we have to do in this case is pick an equation to multiply by something so that we can get those coefficients to be opposites, and then they'll cancel. I'm going to go ahead and pick my x's because they're already both being multiplied by 3. I just need one of them to be multiplied by a negative 3. So I'm going to take this entire first equation, golden rule of algebra, I'm going to multiply both sides by a negative 1. I'm going to write that off to the side here. So negative 1 times 3x gives me negative 3x. Negative 1 times negative 4 gives me a positive 4y. And negative 1 times 4 gives me a negative 4. I'm going to leave that second equation alone. I'm just going to rewrite it. We had 3x plus 2y equals 34. Now I'm going to add my equations together. And now my negative 3x plus positive 3x will cancel. 4y plus 2y gives me a total of 6y. And negative 4 plus 34 gives me a total of 30. Solving for y, I'm going to divide both sides by 6 to get y equals 5. Now we need to solve for x. And when we do that, you have to go back to one of the original equations, not the equation that you multiplied. So one of these two equations. I like the first equation because it equals 4, which is a much smaller number than 34. So I think it might be easier to work with. So I'm going to take this first equation, 3x minus 4y. We just learned that y is 5, so I'm going to substitute that 5 for y, solving for x. Multiplying my 4 and my 5 together, I get a 20, keeping track of that subtraction sign. Now we have a two-step equation. I like the two steps. They're pretty quick to solve. So adding that 20 to both sides, I get 3x equals 24. And dividing both sides by 3, I get x equals 8. As always, expressing my answer as an ordered pair, we're making this connection back to if we were graphing these lines would meet at the point 8, 5. All right, one more. This time, none of my coefficients match. I notice my x coefficients are 8 and 4, they don't match. My y coefficients are 2 and 1, they don't match. So what I need to do is multiply by something that isn't 1. I notice that 4 goes into 8 and 1 goes into 2. Since 1 and 2 are smaller, I'm going to look at making my y's cancel. So I'm going to multiply this second equation, first of all, by 2, because I want both of my y's to be multiplied by 2. But my first y is multiplied by a positive 2. So I want my second y to be multiplied by a negative 2. I'm going to rewrite this first equation. I haven't multiplied that by anything. And then I'm going to multiply my entire second equation by negative 2. So distributive property, negative 2 times 4x gives me negative 8x. Negative 2 times 1y gives me negative 2y. And negative 2 times 5 gives me a negative 10. Adding my equations together, 8x plus negative 8x cancels. 2y minus 2y cancel as well. So if I have 2y's and I take away 2y's, I have 0, I have nothing. Same thing with my x's. Now, both of my variables disappeared, so this is a special solution. Let's take a look at what happens on the right side. 16 minus 10 gives me 6. So when all of my variables disappear, I ask myself if the equation is true or false. 0 equals 6 is false. So this means that these two lines would be parallel, which means they do not meet, so they have no solution. So when you're solving a system by elimination, you want to see how you can get one of the variables to cancel. Thinking about those coefficients, those numbers that are being multiplied by the variable, how can you multiply one of them to make it match the other coefficient, yet be opposites, so that when you combine your two equations, one of those variables, or both if you get a special solution, will cancel. Please reach out to me with any questions, and I will be providing feedback on your assignment as well. Take care.